Welcome to The Explainer. Today, we are diving into a skill that I'm telling you is a total game changer for programmers. We're talking about debugging. So if you've ever found yourself completely lost, hunting for a bug in your code, you're going to want to stick around. We're about to make your life a whole lot easier.
Okay, let's get right into it. We're going to kick things off by talking about the one thing we've all done to find bugs, and why there's a much smarter way to do it.
Yes, this. Does this look familiar? I bet it does. You know something's wrong with your code, so what do? You start sprinkling printf statements absolutely everywhere, right? You're just trying to see what a variable is at a certain point. It's messy, it's slow, and let's be honest, half the time it just feels like taking a wild guess in the dark.
So here's the difference. You've got the messy way on one side, littering your code with all those print statements that you just have to go back and delete later. It's a pain. But then, there's the smart way. Imagine if you could just pause your program while it's running, peek inside to see the value of any variable, and then control exactly how it continues, one line at a time.
Well, that amazing tool is called a debugger, and I'm not kidding when I say it's the closest thing programmers have to a superpower. It's like having X-ray vision for your code. It lets you see what's happening on the inside as it's happening, turning those frustrating bug hunts into a totally precise, efficient process. So how do we get this superpower? What do we need to know? Let's open up the toolkit and look at the essentials you need to start debugging in Dev C++ like right now.
Getting started is actually super simple. It's just two steps. First, you have to compile in what's called debug mode. This is absolutely crucial. It tells the compiler to add in some special information that the debugger needs to work its magic. And second, you set a breakpoint.
So what on earth is a breakpoint? You can just think of it as a pause button for your code. You find a line where you think the trouble might be starting, you click on it, and you're literally telling the program, hey, when you get to this exact spot, just stop. I want to take a look around. It's that simple.
Now, once your code is paused, these three commands are basically your remote control. Step over just runs the current line and stops at the next one. Step into is for when you hit a function and you want to follow the code inside that function. And step out gets you back out. For today, we're really just going to focus on the one you'll use 90% of the time. Step over, which is just the F7 key.
All right, theory's great and all, but this stuff makes way more sense when you see it. So let's put a super simple piece of C code under the microscope and actually walk through a debug session together, step by step.
Okay, here is our very simple program. All it does is declare a couple of variables, add them together, and print the result. But notice that little red dot, that little stop sign next to the line int x equals 10? That's our breakpoint. We've just told the debugger, the second you get here, I want you to freeze.
Okay, you ready?
Let's fire this thing up and start our very first debug. I'm going to show you exactly how we can take control of the program's flow. The first thing we do is press F8. That's the command to start the debugger. So the program will compile, it'll start to run for a split second, and then, bam, it's going to hit our breakpoint and pause right on that first line inside our main function. And just like that, we're paused. See how the line int x equals 10 is highlighted? Now this is a really important point. The program has stopped before this line is executed. Right now, the variable x doesn't even exist in memory yet. So what do? We're going to press F7, which is our step over command. This tells the debugger, okay, go ahead and execute only this one line, and then pause again. Boom, the line is executed. And now, if you look over in the debugger's watch window, you'll see that the variable x has popped into existence and it has the value 10. The debugger has automatically moved its focus to the very next line. See, we are in complete control here. So let's do it again. We're going to press F7 to step over the current highlighted line. And there we go. The line int y equals 5 is done. Now we can see both x and y and inspect their values. We know exactly what the state of our program is at this precise moment in time. No guesswork needed. All right, let's go ahead and execute our final calculation. We'll press F7 one more time to step right over this line. And that's it. The addition is complete. We can now look at our result variable and confirm, yep, its value is 15.
We've seen exactly how our program works from the inside out, and we didn't have to write a single messy printf statement to do it.
And really, that's the whole idea. With a debugger, you are in the driver's seat. You can stop your code whenever you want, you can look at the value of any variable at that exact moment, and you control the flow one line at a time. It completely changes bug hunting from frustrating guesswork into a precise, logical investigation.
Seriously, learning to use a debugger is one of the biggest leaps you'll make as a developer. Now that you've seen the basics, there's really only one question left. What hidden bug in your own code are you going to find first? Thanks for watching The Explainer.